Hello everyone, today we're looking at Unit 0, Lesson 2, Linear Equations, y equals mx plus b. So there's two different forms of equation of a line that we're going to take a look at in this unit. And the first one is this y equals mx plus b form. It's also known as slope y-intercept form. I'm just going to write that underneath our equation here. So slope y-intercept. Okay, and the reason that it's called slope y-intercept is because the characteristics of the line that you are able to pull out of this graph are the slope, which is represented by the variable m, and the y-intercept, which is b. So we're just going to write here that m is our slope. Remember, we were looking at that in the previous day's lesson, and slope and rate of change, those words are used interchangeably. And b is your y-intercept. We'll take a look at what these mean when we transfer them to a graph. Y-intercept, though, hopefully we can remember our y-axis. So the y-intercept is going to be where does the line cross the y-axis, that it intercepts that y-axis, so it's called the y-intercept. So we're going to look at these equations below and state the slope and the y-intercept. So remember, if I was just to write y equals mx plus b over this existing equation, right? It looks like there's a 4 in for my m and a 2 in for b. So my slope is 4, again, or you could write it as 4 over 1, because 4 divided by 1 is just 4. And your y-intercept is a positive 2. Always important to pay attention to the sign on both of these. Are they positive or negative values? Okay, for the next one, our slope is 2/3. And our y-intercept in this case, right, there's a negative on that 5, so our y-intercept is a negative 5. The slope in our next example, so again, if we were to write y equals mx plus b, we have an m here of -3 or -3 over 1. Our b value, though, there's nothing here, right? So we could say that this was plus 0. So that means our y-intercept is happening at 0. So now we'll try to go the other way. If we're given our slope and our y-intercept, can we write that equation y equals mx plus b? So y equals mx plus b, just getting comfortable and used to that equation. We're going to substitute in a 2 for our m and a 5 for b. The next example, 3/4 is our m value and 2 is our b value, making sure that we input those y and x. Okay, and then the last one is y equals 3x. And now we have a b value that's a negative, so we'll do a -1. Okay, so be sure to include those x's and y's in the equation. All right, so let's see if we can now take a look at a graph and determine what's our slope, which we did in the previous day's note, and then what is our y-intercept. So I'm going to use blue for our slope. So remember, our slope is simply our rate of change, or our rise over our run. So if we pick, and I'm just going to write here again, rise over run. So if I start on a point that crosses the grid line, I'm going to use that point, and this point here looks like it crosses. So the rise from this point, we're going to rise 2, and we're going to run 1, 2, 3, 4. So both of those are positive. So 2 over 4, we need to make sure we put that in simplest terms, 1 over 2. Okay, and then our y-intercept, maybe we could have used a different point. Okay, but our y-intercept is right here. It's where does the line cross the y-axis? Okay, so what's that coordinate? That coordinate is 0, 1. So we say our y-intercept is our y value. Where does it cross the y-axis? It crosses the y-axis at a positive 1. So now we have our slope, we have our y-intercept. We should be able to write our equation in y equals mx plus b form. So y equals my slope of 1/2 x plus my y-intercept, which is 1. Okay, I'm going to try the next one, and then we'll get you guys to try that third one. Actually, we'll move down, and then I'll get you guys to try the one to the right on your own. So let's take a look at, again, determining our slope. So I'm going to choose this point and this point. They look like they cross. So it looks like I'm going down this time 2. So my rise is a -2. and my run is a positive 1. So my slope is a negative 2 over 1, or just negative 2. Okay, and then my y-intercept, where does it cross the y-axis? Crosses the y-axis right there. Well, that coordinate is 0, 0. So my y value is 0. So now we could write our equation as y equals negative 2x. And we can write plus 0, but we saw in the example above that if the y-intercept is 0, you can just leave it because you don't need to write mathematically plus 0. Okay, I'm going to try the next one down and then get you guys to try one. Okay, so this one is a little bit unique. You can see here that we have a vertical line. And we talked about this in the previous day's notes, that you can't really measure the slope of a vertical line because it's not something somebody can climb, right? A slope measures the steepness of a line, and so you can't measure how steep a vertical line is because it's not possible to climb. So if we wanted to measure our rise, well, let's just pick any point. Let's say from here to here. Our rise would be 2. Our run, how much do we have to move left or right, is 0 though. So our slope is undefined, and this is always true of a vertical line. So let's just make a note. This is the slope of all vertical lines. Okay, all vertical lines have an undefined slope. What's our y-intercept? So where does that line cross the y-axis? Well, it doesn't cross the y-axis at all, right? Do we see it cross our y-axis? This is our y-axis, right? It never touches that, so there is none. So I have an undefined slope. I have a y-intercept that doesn't exist. So you might be saying, well, how do I write an equation for this? So the way we write an equation for a vertical line is we take a look at what is consistent about the line. And what is consistent about the line is if you look at some of the points. So this point here, for example, is negative 2, negative 1. And if we look at this point here is negative 2, 2. Okay, we'll look at one more. Let's take this point. So this point is negative 2, 2, 3, 4, 5. Negative 2, 5. Okay, this line consistently has x values that are negative 2. So that's how we write the equation of a vertical line. We say it's all basically x values being equal to negative 2. Okay, so just to make a note here, x equals some value, we'll call it a, is the equation for vertical lines. It's a special case of lines. Okay. Pause the video and give the next one a try. See if you can determine the slope, the y-intercept, and the equation. Okay, there's the equation of the next one. Hopefully you're able to get a slope of 3 and a y-intercept of negative 2, which makes your equation y equals 3x minus 2. We're going to look at another special case. This time we have a horizontal line. And so we talked about, again, in the previous day's notes, what is the slope of a horizontal line. So we will look at any 2 points. Let's go from left to right here. Our rise is 0. We don't have to go up or down at all to go from one point to the next. And our run is 2. So that makes our slope 0. Now the y-intercept of this line, where does it cross our y-axis? It's crossing our y-axis at 0, 2. So our y-intercept is a positive 2. So if we were going to write this as an equation, this one you can kind of plug in everything and see how it will simplify down. So our equation is going to be y equals 0x plus 2. And then the 0 itself can just cancel out because 0 times anything is 0. So we don't need to write it there. So we could just write the equation as y equals 2. Okay, and this is the equation for all horizontal lines. So we're just going to write y equals, we'll say b this time, okay, is the equation for horizontal lines. And something also to point out, our slope for horizontal lines is always going to be 0. So this is slope for all horizontal lines. Once you kind of know these rules about horizontal and vertical lines, they're easier to work with and come up with the equation for, but we'll spend a whole day just on vertical and horizontal lines to give you some practice. Okay, the last equation we have here, the last graph rather we have here, we need to make sure that we're paying attention to the scale. So I just want to write down here, pay attention to scale. And what I mean by scale is those numbers on our x-axis and those numbers on our y-axis. They're not always going up by 1. So if we look on our y-axis here, each line actually goes up by 10 on our y-axis, and along our x-axis, they're all going up by 2. So we just have to pay attention to that scale when we're determining what's our slope, what's our y-intercept. So let's start with our slope. Let's pick a point. This one looks like it, oops, I need my pen. This one looks like it crosses right there. And then I'm going to pick this last point. It looks like it crosses the grid line there. So I'm starting at 70, and then I'm going to rise up to 90. So that's actually a rise of 20. And then along my x-axis, that point is lined up with 10. And it goes from 10 all the way to, that looks like it's a 20. So from 10 to 20, I have a run of a positive 10. So my slope is going to rise 20 and it's going to run 10. Okay, so that means it's going to be a 2 over 1 or just 2. Our y-intercept, where does it cross my y-axis? It crosses my y-axis right there. So it crosses at 50. So we just have to make sure, again, we're paying attention to that scale. Our equation is going to then end up being y equals 2x plus 50. Okay, now we're going to take a look at how do we go from our equation to actually being able to graph the line ourselves. And so there's a couple steps here. We're going to first always start with our y-intercept. So let's identify our y-intercept. So our y-intercept is a -3 in this first equation, right? 1/2 x minus 3. Our y-intercept is -3. So step 1 is we're going to plot our y-intercept. So if we were going to rewrite that as a ordered pair, as a coordinate, it would be 0, -3. So I'm going to plot that point. Let's label our y and our x-axis just so we remember which is which. So if I plot 0, -3, that's going to be right there. Okay. Then we need to identify what's our slope. So in this case, our slope is 1/2. Okay. So we're going to use that slope. So we're going to plot points starting from our y-intercept. And we're going to use our slope to do so. So our slope is a rise of 1. So a rise of +1 means we're going to go up 1. And then it has a run of 2. So that means we're going to move to the right 2. Okay, if it was negative for our rise, we'd go down. And if it was negative for our run, we'd move to the left. All right, but we're going to start at this point here. We're going to start right at our y-intercept. And we're going to go up 1 over 2 and plot the next point. We're going to go up 1 over 2 and plot our next point. Okay, you don't need those little dot marks. I'm just doing it to show the pattern of up 1 over 2 and plot your point. Okay, and then we're going to go ahead and draw a straight line, making sure to always use a ruler or a straight edge so that you have a line that is actually straight. Okay, so I'm just going to label that as graph A. So it goes along with equation A. All right, and then we will give this a try with B. So this time our y-intercept, that's the first thing we're going to do, is a 6. So our y-intercept, if we were to write it as a coordinate, is just going to be 0, 6. So we'll plot that point first. 1, 2, 3, 4, 6. And then our slope is a -2/3. So that means we're going to go down 2, and we're going to go to the right 3. So again, from that y-intercept where we just started, we're going to go down 2 and over 3, down 2, over 3. Okay, and then you will again make your straight line. Okay, and one thing I forgot to mention, you need to make sure you put arrows on the ends of each of your lines, just to show that those lines go on indefinitely in either direction. And I'm going to label that next one we just graphed as equation B. Okay, take a minute and see if you are able to graph C, y equals 2x plus 3 on that next graph. Okay, that is the graph for the equation of C. Recognizing that your slope, even though it says 2, is 2 over 1. So you would go up 2, right 1 from your y-intercept at 3. Try D, but before you do, let's just recognize that you have y equals negative 2x here. We don't have a y-intercept, so remember that we can just assume that this is a plus 0. Okay, and just like on C, remember that our slope, this would be a negative 2 over 1 if it helps you identify your rise and your run. So take a minute and try to graph that one as well. Okay, and that's your graph for equation D, y equals negative 2x. The next thing we're going to do is see if we can determine the equation now based on a table of values. So we're working back and forth between all these different forms, working from an equation to a graph, working from a graph to an equation, and then let's see if we can work from a table of values now to an equation. So again, we still have to identify those two things. We have to determine the slope, we have to determine the y-intercept, and we have to write our equation y equals mx plus b. So let's first determine our slope. Okay, so our slope is going to be our change in our y values divided by the change in our x values. So if I just look at what's happening with my y values here, I can pick any two y values, and it looks like if I go from 7 to 4, that's a decrease of 3. And if I look at the corresponding x values, those are going up by 1. So we could say my slope is a negative 3 over 1. Okay, then we'd have to identify our y-intercept. Okay, so our y-intercept, as we saw in all of our previous examples when we were trying to go to our graph, our y-intercept always occurs where our x value is 0. If you look at all of my y-intercepts here. So wherever x value is 0, that is going to be our y-intercept. So for example, our y-intercept for this first one, our x value is 0. So this is going to be our y-intercept. So our b value is 10. So the last part would be to write our equation. Well, we have our m, we have our b. We've had some practice at this now. So y equals negative 3x plus 10. Okay, take a look at your next one. Again, if we take a look at any two y values to figure out our slope, looks like it's going from 6 to 12 here, so that's an increase of 6. As my x value, my corresponding x values are going up by 2. So my slope is going to be a positive 6 over a positive 2, okay, or m is going to equal 3. All right, our y-intercept, again, is going to be wherever x equals 0. So that's going to be my y-intercept. So b is equal to 0. And then our last part is to write our equation. So my m value is 3, and my b value is 0, so we don't need to add it on there, right? We know plus 0 doesn't actually need to be written mathematically. Okay, our next and last one here, let's identify first our slope. So what's happening as we move from one of these y values? We'll pick those two in the middle again. So as I go from 36 to 24, my y is decreasing by 12. Those corresponding x values show that my x's, however, are increasing by 3. So our slope is going to be a negative 12 over 3, which works out to be a negative 4. Okay, now we have to figure out what's our y-intercept. And on the other tables, we were able to do so wherever x was 0. Well, on this table, we don't have an x equals 0, but we can kind of work ourselves backwards or put those values into our table based on the patterns that are happening. So we know that as our x's increase by 3, our y's decrease by 12. So if I wanted to work backwards, right, to try to get to 0, I know that from whatever this x value is here, I had to add 3 to get there. So what number plus 3 gets me to 3? Okay, that would be 0, right? So 0 to 3, okay, that sticks with my pattern. So I should be able to match the pattern with the y's as well. So I know that whatever gets me to 48, I had to subtract 12 from something to get to 48, right? So some number minus 12 will get me to 48 if I was working my table backwards. So if I went the other way and said 48 plus 12, okay, this would be 60, right? So then 60 minus 12 gives me to 48. That sticks with my pattern of minus 12 each time. Okay. So now we have a 0 in our table of values. We can see that that then is going to be our y-intercept. Okay, so our b value is going to be 60. So the last step is to write our equation. So y equals a negative 4x plus 60. Okay. The very last thing that you might be asked to do occasionally is figure out if certain points actually lie on a line. So this is going to be a simple sub in and kind of see if things work out. And we're actually going to set up a left side, right side check for each of these points to see if they work on the equation there. So let's just make a little note here. We're going to take each of these points individually. We're going to sub in each point into a left side, right side check to see if the left side equals the right side. Because whenever we're talking about an equation, left side equals the right side of the equation. Right? We should think of an equation as something being balanced, right? We need the left side of our equation to equal the right side of our equation. That's why we put that equal sign in between them, because the sides should be the same. So let's start with point P, which is 3, 1. So I'm going to set up a little left side, right side. And all we're going to do is we're going to put the left side of our equation on that part of the t-chart. And this part here is the right side of our equation, so that'll go in our t-chart. So the left side of my equation is y, and the right side of my equation is 2x minus 5. And then we're going to substitute in for x and y. So on point P, my y value is 1, and my x value is 3. So we'll just continue to simplify. 2 times 3 is 6. 6 minus 5 is 1. So if we look, right, the left side equals the right side. So that means that point must fall on that line. So I'm going to put a check here right now, but we know that point P does actually work. Okay, let's try point Q, which is 2, negative 5. We're going to, again, set up a little left side, right side check. So my left side, again, is y, and my right side is 2x minus 5. So my y value of this point is negative 5, and my x value is 2. 2 times 2 is 4. 4 minus 5 is a negative 1. So this time our left side does not equal our right side. So we could say left side and then cross out our equal sign to show that it does not equal. So point Q is not one that's going to end up falling on that line. We will check that last one though. So R is negative 3, negative 11. Let's check it in a left side, right side check. So in for my y value, this time goes to negative 11. And we're going to substitute in a negative 3 for x. 2 times negative 3 is negative 6. Negative 6 minus 5 is a negative 11. So it looks like the left side and the right side do equal each other for this one. I'll put a check. So we could make a little conclusion here, right? We'll use those 3 dots to form a triangle. It means therefore. So therefore points P and R are on the line y equals 2x minus 5. It's showing that those 2 points must fall on that line because when I plug in a point, it satisfies the left with the right being equal to each other. All right, that's it for your note for today.